Hi students, today I will discuss a new chapter of information theory and coding, which is convolution code. The topic which will be discussed here about a convolution theorem or about the convolution code, structure of convolution encoder, properties of convolution code, examples with a problem, required formula to solve the problem, and lastly you have to give an exercise to do yourself. In case of NK block code, we have seen that for a binary code, n bits code word are constructed depends solely on k bit of information. But in case of convolution, present information bits are not only solely used to construct code word but also using some of previous encoder inputs, which is regarded here as memory or M. In convolution code, block of encode digits are generated by the encoder in time unit, and that depends not only on block of k message digit within that time unit but also in the preceding m-1 block of message unit called memory. So basically in this system, number of unit of information bits are combinedly encoded and the input bits are stored in fixed length shift register. Now, in a shift register, each time when a new input bit is entered into the register, the previous content which are already stored in it are shifted by one position. That's why it is called shift register. So we can say that in this coding system, the previous bit and the current information bits are combinedly encoded here. The convolution encoder will looks like the following figure. For this figure, the shift register contain three information bits, M1, M2 and M3. Here, M1 is current message bit and M2 and N3 are previous successive two message bits. We have two output here. The information bits are combined by these two output in a specific manner. The outputs are X1 and X2. They are nothing but the modulo 2 adder. From this figure, we can conclude that the value of X1 equals to M1 plus M2 plus M3. All three are all three additions are modular addition. Similarly, X2 equals to M1 plus M3 because you can see here M1 and M3 both are connected with this modulo adder, but there is no connection between M2 and the modular adder. Therefore, this part is omitted here, where we can say M equals to, that means capital M equals to 3, K equals to 1 and N equals to 2, where capital M is constant length, which will be discussed in the next slide. K is information bit stream and N equals to output. In every time for a new input bit in the register, the value of output will be changed. Now we go to the next slide, that is properties of convolution code. The first property will be the code rate. It is defined as the number of shifts over which a single message bit can influence the encoder output. So K equals to, or code rate R equals to K by N. In our previous example, we can see that initial there is no content in the shift register. So we can say before starting of any operation, ideally it is taken as the system are to be reset. So number of bit present here is 0. Now comes to the constraint length M. So as the initial or as initially the all the bits in the shift register are 0. So whenever an input is entered into the shift register, it is stored in the first location of the shift register, which is M3, denoted here. For the same output, for this the some output will be reflected as x1. For this sequence, that means M3 equals to 0 and other 2, that means first location is 0 and other 2 will be sorry, M3 will be a value, that means first location will be a value and rest 2 locations are 0. For this there will be some output at the decoder, the encoder in output. Again for another input M2, M3 is shifted here by one location and M2 is entered into the first location. For this, another output will be produced in the output section of the encoder. And lastly, M1 when entered into the or the third input will enter into the shift register. M2 is shifted second location and M3 is shifted in third location. For this another output will be created. Every time an input, whenever an input is entered into the encoder, the output is consequently changed. So as the capacity of the shift register is 3, hence no more input is provided for this example. So here capital M equals to 3, where M is the single message bit that can influence the output of encoder for 3 successive shifts. As here M3 is shifted 3 times. You can see that M3 is shifted 3 times, for first location to second and second location to third. So that means this is called constraint length. So formally the definition of constraint length is, it is defined as the number of shift over which a single message bit can influence the encoder output. The third property is code dimension. Dimension of code is denoted by N, K and M, as you show here, where K is the number of message and N is the number of encoded output bit at a particular time, and capital M is the constraint length or memory. For this example, N equals to 2, K equals to 1 and capital M equals to 3. So we can denote here 2, 1, 3. Now one thing you may arise in your mind, that why there is shift 3 location in the shift register, but we can that means there is 3 information, but the information bit sequence is taken here as 1. Why? Because this shift is taken for at a time for one instance. That means here these 2 bits, that means M2 and M3, are the previous bit or previous order bit of the information, which is also called memory, and the current bit is only M1. So as current bit is only 1, therefore we denote here K equals to 1. Now if we want to calculate the previous example, we have to consider the following formula. X1 equals to G1 plus M1, G1 into M1 plus G2 plus M2 plus G3 plus M3. Note that all 3 addition will be the modular addition. and x2 equals to g1 dashed m1 plus g3 dashed m3. You can see here g1, g2, g3 are the link which is connected to x1, and g1 dash g3 dash are the link which is connected to x2. So from that we can get the output x equals to x1 comma x2. Now we have to consider one problem. Consider the previous example where input sequence is given, that is 1101, and some dot is placed here. Why this dot is present? Because the input is the binary sequence and it may be infinite length. That's why we taken as a dot dot value. So the first 4 bits is here 1101. That means M1 equals to 1, M2 equals to 1, M3 equals to 0, and M4 equals to 1, which gives the following result. Put the value of G1 and M1, because G1, whatever the link is given to the X1, if a link is present between X1 and the shift register, G, the consequent G is to be considered, and if there is no link, that means that G value will be 0. By this way we can calculate this. Similarly, for the second output, that means x2, we can calculate this. So our final output will be x equals to, we put first value, that means first output of the encoder, which is x1, then we can put the second input value, that is x2. So the final binary sequence is this. You can see here that there is also a dot present, because as the input sequence is infinite, so it creates the output sequence, it makes the output sequence also infinite. Here you can remember that for a finite input sequence or for a infinite input sequence, we need to ensure that the last input fit through the register and appear at the output. That means for a infinite sequence of message bit, the last location of the register, shift register, link should be connected with the output. Otherwise, the problem cannot be solved. So, up to we can, by this way you can calculate the total problem. Now you are given here a problem is given to you. The input sequence is also given to you. You have to find out the output sequence. Do yourself and send me the result in a Google Classroom form comment section. Thank you.